Okay, so we are starting Unit 2. Not going to tell you much about it. Going to do a lot like Unit 1 where we're kind of asking questions, using student inquiry to drive through Unit 2 and develop your learning, student-led, student-centered, everything. Teacher doesn't have to do much but just guide you. So we're going to start off with our notes today. This is 10/22/19, and we are going to be doing a new phenomenon. And it's going to deal with smell. And I want us to start off here, first of all, with a little journal question that I want you to answer on these notes. I'll come around and look at them. Okay? And the journal question is right here. Okay, so really quickly in your notes, I want you to try and answer this question. Remember that this is chemistry class. We've been dealing with particles a lot, composition of matter. That's what we do. Our learning target is that we're learning to describe particle behavior. And our success criteria today is that we're going to develop and use models. So just take a couple minutes in your head. Try to answer this question. How do we actually smell things? What happens? Okay, so I saw a lot of great answers as I walked around the room. You guys did a nice job talking about particles. A lot of people don't really understand how we actually smell, but it is similar to taste, very similar to taste. Okay, when we eat something, we chew the food, we break it up into smaller particles. Those particles will join receptors on our taste buds that'll send a signal to our brain saying, hey, this is what you're tasting. Same thing happens in our nose, but obviously we don't chew the air, whatever gases are joining into our nose, but particles are going to bind to receptors in our nose. So we are talking about particles, and in this time we're kind of talking about gases more than like solids or liquids like we would talk about with taste, okay? So this is going to be our demo today. We are going to do a pod C, but we're going to start with our prediction, and then you guys are going to make observations, and then you're going to describe and discuss, and we'll worry about the other stuff later. So let's start with our prediction, okay? So first of all, if anybody in here is very sensitive to smell or aerosols, let me know before I actually do the demo. But what I'm going to do is I'm going to stand in that back corner, and I'm going to take some pine air freshener, and you guys are all just going to sit there, and I'm going to spray it around back here. But I'm going to spray quite a bit around back here in this corner. And what you're going to do is you're just going to sit there. But the second you smell it, you're going to raise your hand and keep your hand up. Okay? And I want you guys to be able to look around at each other, but try not to be influenced by other people. Like if you see somebody nearby raise their hand, you might be tempted to raise your hand even though you don't actually smell it yet. Okay? So try not to stay biased. So we're going to be raising our hand the second we get the smell, and we're going to keep our hand up. And so I want you to make a prediction about how you think this phenomenon is going to go. Okay, so I know this is kind of hard to show through video, but I stood in the back corner. I sprayed the air freshener. People raised their hands, kept them held up, when they first smelled the smell. Okay, so anybody want to share observations with me? Moses. The particles looked like they kind of, you could see it when it came out of there, right? It looked like it. Okay, cool. Excellent. Great answer. Great observation. So when it first came out, you could see the stuff coming out of the can. It kind of went up, and then it kind of started to come down, and as it came down, it disappeared. Okay? Any other observations we want? Maybe I should note that on here. So we could see spray at first. It went up, then down. It disappeared when it started to go down. Okay, so there's some observations there. Other observations we can add. People in the back. People closest. Okay, people closest smelled it. Were there some people that didn't smell it at all? Okay, so we had some people didn't smell it at all. Didn't smell, we'll call it the odor at all. And those people were farthest away, right? Anything else we could say? Anything else we can say about that? Can we be a little more detailed on that last part that Teresa said? Can we be a little more detailed in our observations? Can we be a little more detailed in our observations on this last part here? Who smelled it first? Besides me. Okay. Ashley, you did? All right, going from there, who smelled it after that? So what is the pattern we're seeing here? There we go. So the closer, I'm going to put an arrow on this one. Closer you are, the quicker you smelled it. So people closest to the odor being sprayed smelled it first. People farther away, it took a little while longer. Some people even farther away didn't smell it at all. Okay, so now what we're on to now, we've done the, unless anybody wants to add to this anything more. Okay, so we have the prediction, we have the observation. Now we are on to the description and discuss. Let's talk about describing individually on our own first. Okay, so remember this is chemistry, so we want to think about particles. And with particles, we want to try to explain why this happened. Okay, so what did the particles do? Why did this phenomenon occur? And what I want you to do is, with this description, is I want you to model. And in this before and after, or I'm sorry, in this model, I don't want to do a before and after. I actually want you to try to make 5 pictures. Okay, 5. This is what we're doing for the remainder of the hour. This is your individual model. Now, first of all, something to consider with modeling is think about everything. First of all, things we can see, things we can't see. But don't get carried away. Like, what is actually relevant? Okay? I remember an earlier quiz, like I said, model a glass of water, half full, when we first started learning about modeling. And people are showing like oxygen in the water or something like that. And like, is that really important? Like, is there really oxygen in water? Yeah, but stop doing that. We don't care. The water is just water particles, all right? Now, if you did air particles above the water, cool, that's fine. But just what is relevant in terms of what particles we need to include in our model? Okay, just use those. And you can be very general, very basic. Odor particles, air particles, whatever you think. It doesn't have to be super specific. All right, but what happened in this phenomenon? Explain why. What did the particles actually do? What caused people that were closest to smell it first and people that were farther to smell it later?